This video deals with the basics of units and dimensions. Students are already aware of units, and let us say that the units of the various physical quantities, uh, which are basically seven fundamental in physics, they are already aware of those units in lower classes. The physical quantities which are fundamental, there are only seven. I'm just mentioning the basic points. The seven fundamental physical quantities are mass, length, time interval. You can call it time, or it is basically time interval. Then these are actually we need for our major discussions. Apart from this, there is temperature, then there is electric current, luminous intensity. Luminous intensity is the intensity of light, and then the amount of substance. Now, out of this, students are already aware of the amount of substance. Actually, this is measured in moles. Now, why we are taking is as fundamental? Because all other quantities whose units we know or we do not know will be expressed in terms of the units of these seven fundamental quantities. That is why we call them fundamental. And the method of showing how other quantities, other quantities means apart from this seven there are other derived quantities. The method of showing how other quantities are expressed in terms of these seven fundamental, or any combination of these seven fundamental, is called dimension. That is, dimension is basically a way to show how the fundamental quantities are going to be used in determination of other physical quantities. And to denote them, we use some symbol. Let us quickly have a look of. The mass will be denoted by m, and we will put a bracket to show that this is the dimension of mass. Length will be kept as L. Time interval is capital T. Temperature is capital K, which will just remind you of Kelvin. Electric current, it is denoted as A, which will remind you of ampere. Luminous intensity will be CD, which at present you may not require, but just keep in mind CD, candela. And the amount of substance is denoted in small letter mol, mol, which is a small abbreviation of mole. So it is basically related to mole concept. Now, based on this, let us try to have a quick look on the basic dimensions of few quantities. For example, velocity. What is velocity? It is displacement by time. So basically it is length divided by time. Means in all cases you have to express it in terms of fundamental. So length is L, and time, so time written upward will be t to the power minus 1. So this will be velocity. Similarly, if you take acceleration, acceleration is change in velocity divided by time. Basically change in velocity is also velocity. So velocity by time. Velocity is Lt minus 1, and another t comes here, Lt minus 2. So we have force. Force is equal to mass into acceleration. So we just attach one m here. So it will be m L t minus 2. That will give you the idea of this force as mass into acceleration. Let us quickly move ahead and have a quick revision of these dimensions. Then work done. You need to know the definitions. Work done is force into displacement. Force into displacement. So displacement means another length, is it not? So here it will be equal to m L to the power 2 t to the power minus 2. This is what work done is. Then See, work done and any type of energy, whether it is kinetic energy or potential energy or any type of electrical energy, heat energy, all will be having the same dimension as that of work done. Other pressure, pressure will be equal to force divided by area. Now, area is basically length square, is it not? The product of two length. Now, force is this. If I divide it by L to the power 2, so we have ml minus 1, T minus 2. And after that, there will be density. Density is equal to mass by volume. Now, mass is m and volume is length to the power 3. So, you can have L to the power minus 3. Then if you move ahead further, there are Newton's universal gravitational constant. We denote it by capital G. So what is this? See, force between any two particles of masses m1 and m2 is given by G m1 m2 divided by r square. So in this universe, this is universal law. So this capital G is basically called the universal gravitational constant. So how much it should be? It will be equal to force into distance square, that is length square divided by mass square. Is it not? So force is how much we just now have discussed, mlt to the power minus 2, L to the power 2, m to the power 2. So finally m to the power minus 1, L to the power 3 and t to the power minus 2. This will be the dimensions of Newton's universal gravitational constant. Let us see the others also. You can pause the video and keep on revising the basics, so that will help you. And to go ahead with the other terms, let us take surface tension. Surface tension, later on you will study that it is basically a ratio of the force acting per unit length. The force acting per unit length, it is related to liquid surface. Now force, what we have discussed, ml t to the power minus 2 divided by L. So L will go ml0 t to the power minus 2 we can write, or we can also write m t to the power minus 2 without writing the term containing L. That is up to you, how do you write. Now another is coefficient of viscosity. It is also a term which is related to between the liquid layers of a flowing liquid. I will tell you. The force of viscosity, basically force is, there is a formula 6 pi r eta into V. Now here eta, this is a Greek alphabet, we denote this for coefficient of viscosity. Now what is this? Coefficient of viscosity will be equal to force divided by, there is no need to divide by 6 pi because it is having just a number, it is having no units or dimensions, and radius is length and this is velocity. So finally you get for the coefficient of viscosity dimension. Now what was force? Force is mlt to the power minus 2, length is L and velocity is lt to the power minus 1. So how much we get? M is there, one of the L gets cancelled and this L goes up, and t to the power minus 1. So this is coefficient of viscosity as ml minus 1 t to the power minus 1. There are many other physical quantities gradually we will be learning. For example, frequency. What is frequency? 1 by time period. Basically time period is time, so we can have t to the power minus 1. Then we have another Planck's constant. What is Planck's constant? Let's see. The energy is equal to h into f, energy of a photon. Photon are carriers of energy, that is they move with the speed of light, and h is Planck's constant, f is the frequency. Now any energy will be same as work done, and what we did for work done, ml2 t to the power minus 2. So therefore Planck's constant is work done divided by frequency. So work done, how much it was? Work done was ml2 t to the power minus 2, and frequency is t to the power minus 1. This goes up. We have ml2 t to the power minus 1. So this will be Planck's constant as the dimension. Then there are many other. Torque. Torque is equal to, basically the turning tendency of a force is torque. Torque is force into perpendicular distance, that is length. Force is mlt minus 2, and another L will be ml2 t to the power minus 2. Now further, there are related to heat. We have specific heat capacity. Specific heat capacity is the amount of heat energy given per unit mass per unit rise in temperature. Therefore, this heat, what is basically heat? Heat is same as the energy, and energy will be equal to work done, which is equal to ml2 t to the power minus 2. If you do not remember what is energy, you can even split that energy into two. That is, energy is work done. Work done is force into displacement. Force is mlt minus 2 into displacement L. So ultimately ml2 t to the power minus 2. And this is mass, and temperature is K. So finally what we get is m gets cancelled. You can write m to the power 0, or you may not write m. So it's up to your wish. L2 t to the power minus 2, k to the power minus 1. You just keep on mentioning, because we are discussing just as a list of formula. Students are advised to learn the basic definitions. Now there is heat capacity. What is heat capacity? Heat capacity is the amount of heat taken by a object to raise its temperature by unit degree. So heat divided by change in temperature. What is heat? Same as energy. ml2 t to the power minus 2, temperature is K. So that is ml2 t to the power minus 2, K to the power minus 1. This will be heat capacity. Then there will be Boltzmann's constant. This you will get in atomic structure, the Boltzmann's constant. You just mention that Boltzmann's constant is work done divided by Kelvin, that is temperature, similar to that of heat capacity. Is it not similar to that of heat capacity? That is Boltzmann's constant, we can have energy by temperature. Basically it is energy by temperature. So what will be Boltzmann's constant? Energy by temperature, m L2 t to the power minus 2, k to the power minus 1. This heat capacity and Boltzmann's constant will be having the same dimension. Then there will be coefficient of thermal conductivity. Coefficient of thermal conductivity. Although it may not be understandable at present, because you may have not gone through the topic, but just as a formality I am just mentioning 2 or 3 more, because there is endless list, and the list goes on. Students are advised to go through the list and remember few of them and derive all of them, because everything you cannot remember. So the coefficient of thermal conductivity, you can remember the unit. From unit you can develop the dimension. So you have this dimension of coefficient of thermal conductivity as mlt minus 3k minus 1. You may remember this. Coefficient of thermal conductivity means, what is coefficient of thermal conductivity? I am mentioning it. Rate of heat flow means the heat that flows per unit time is equal to this coefficient of thermal conductivity into area into change in temperature divided by distance. From this, students are advised to derive it. See what I have taken. Rate of flow of heat, that is rate of heat flow is thermal conductivity into area into change in temperature by distance. All these are known to you. Rate of heat flow means energy per unit time. From their coefficient of thermal conductivity can be worked out. You will get this ml T to the power minus 3 K to the power minus 1. Then you have magnetic field intensity. Magnetic field intensity. It is also called magnetic induction. So this you remember, force is equal to BIL. That is, you might have studied Fleming's left hand rule. So that is the force experienced by a current carrying wire placed perpendicularly in magnetic field. Here B is the magnetic field. So from this we can say that it is force divided by current and length. What is force? Same, mlt minus 2. Current is A, you remember, and length is L. So you just see L gets cancelled. M A to the power minus 1 T to the power minus 2. You can write T earlier also, that is M T to the power minus 2 A to the power minus 1. This is basically magnetic field intensity. Just check this dimension.